Okay, so for this video, we are going to continue with case number 2 for confidence interval for mean. Right, so just to recall back, what is the case number 2? What is the criteria for case number 2 for the confidence interval for mean? So first of all, you will see that the population is not normal. So you won't see the word normally distributed in the question. And after that, you must know the variance. Population variance is known. And after that, the sample size must be large. If let's say the sample size is small, then you cannot actually find the confidence interval. All right, so why we need to ensure that the sample size is large in this case is because of the population variable is not normal. Then when the population size, the sample size is big, is large, then only the sampling distribution is normal. So that's why only you can use all these criteria to calculate the confidence interval for population mean. All right. Okay. So generally, all the formula are still the same in case number 1. All right. So you just need to make sure that you know the criteria only lah. So case number 2 and case number 1 generally are more or less the same. Okay. All right. Then if we continue further, case number 3. So case number 3, the biggest difference is they said population variance is unknown. And then it must be large also for the sample size. And then because of the population variance is unknown, therefore you have one extra step, which is you need to calculate the unbiased estimate for the population variance first by using the formula that we learned before in part number 1 of this chapter. Okay, then after that, only you use the value calculated here and you put it into the formula for the confidence interval. All right, so case number 3 is quite different from what we have in case 1 and case number 2. All right, so we have discussed all the case number 1 example, so I will just skip all this. So we'll straight away start with case number 2 example here. Okay, so you can read the question first before we start. All right, so for me, because of this is only one sentence and I can see the word random sample in the sentence, so I assume that this whole sentence talk about a sample. All right, so if you look through the whole question here, they didn't mention any word about normally distributed, so you know that the population is not normally distributed. But you see this one, 100 men. So this 100 men actually tells you that the sample size is larger. So n equals to 100. Okay. All right. And then they said the 95% confidence interval for the mean height of the mean in the district is found to be this one. So they already give you the confidence interval value. So by using these two confidence interval value, they want you to calculate the value for mean, the sample mean, and also the population variance. All right. So for this one, I think you just need to solve simultaneous equation. So which means how to get the 177.22. The formula is x minus z, then sigma over square root n, which is equals to 177.22, right? Okay, so you can put in the value. So the sample mean you don't know. What's the value of z here? So for 95%, the z should be 1.96. So again, if you already forget how to find the value of z, please refer back to the video, okay, earlier. All right, so sigma you also don't know, but you know that the n is 100. So equals to 177.22. Okay, so this is the first equation that we have. And of course, you can form the second equation. So the second equation will be x plus 1.96, then sigma you don't know, divided by square root 100, and you get 179.18. So this is the second equation. All right, so this is very straightforward. From here, you can now try to solve the simultaneous equation. So I'm not going to show you the details. You try to find out. So complete the steps here, right? So please complete the steps here. Eventually, your answer should be sample mean equals to 178.2, and then the sigma that you get should be equals to 5. So this will be the final answer for part 1. Okay, so please take some time to solve it out. Solve the simultaneous equation, which is quite easy. Okay, then now we go to part number 2. Alright, so what they want for part number 2? So for part number 2, they want you to calculate the 80% confidence interval for mu based on this sample. Alright, so based on this sample means that you can use the value for the sample mean and also the population variance that you find just now, okay, to use them and apply to get the 80% confidence interval. Alright, so we can start. So 80% confidence interval, what do we have here? Okay, so the formula is sample mean 178.2 minus the Z. So what is the Z for 80%? If you want to test your understanding, you can pause the video here, try to find the Z first. Okay, so if you didn't do any careless mistake, the Z should be 1.282. Then you substitute the sigma and also the N 100. Same thing happened for the upper limit. Alright, so from here, very easily you can get the answer 177,559. And after that, of course, you can round it off to 3 significant figures, so which is 178 and also 179. Okay, so this will be the answer for part number 2. Okay, alright. Then now we go for part number 3. They are asking what is the probability that 80% confidence interval does not contain mu. Alright, so this one is very simple. It is an understanding question, but very simple. Before that, I told you, right, the confidence level tells you that what is the percentage that confidence interval contain mu, right or not? So like 80%, that means 80%, we are 80% sure that the confidence interval contain the population mean. So for now, they are asking for does not contain the mu. 80% contain mu, so that means 20% does not contain the mu, right? So you just write out 0.2, that's it. Right? Okay, then for part number 4, also understanding question, something about concept, all right? So find the probability that the 80% confidence interval contain mu, but the 95% confidence interval does not contain mu. Okay, so this one I think we need to do some simple imagination. All right. Okay, so let's say let's say this is the mu that you have. So the mu should be this value, okay, but I don't know what is the value. All right, so I'm having 2 confidence interval. 80% confidence interval. If you look at the graph, 80% means the area is smaller one. Okay, and then for 90% confidence interval, if you draw the graph, sorry, we should have the same graph. Sorry for that. Okay, so we should have the same graph because they're using the same sample and everything, right? So 95% means that the confidence interval is wider because you can see that the area cover is wider for 95%. So 0.8 means slower, smaller. And then both of them are using the same sample mean, correct or not? So that means if let's say the 0.8 is a shorter confidence interval. So this is a shorter confidence interval, already contain the mu. Alright, so that means if the same thing happen for 95% confidence interval, it is wider, but generally they are still based on the same sample mean. Okay, so is it possible that the mu is not in the 95% confidence interval or not? It is impossible, right? Definitely the mu will be inside the 95% confidence interval one. Alright, So for this example, the answer is impossible. So the probability is equals to 0. Because the 80% confidence interval is smaller, the range, 95% is larger. So if 80% contain a mu, then definitely the 95% one definitely also contain the mu lah, unless they are using two different sample. So that is other story. Okay, but we are using the same sample here. So no matter for the same sample, if 80% already contain the mu, then 95% definitely also contain the mu. Okay, so this is what you have for this example. So this is for case number 2. So throughout this question, right, actually you didn't see any keyword about normally distributed. So from here you know that the population is not normal. All right. Okay, so if no problem, then maybe we can proceed to the next example. Okay, example 24. So example 24 belongs to case number 3 lah. Okay, so first they're asking, give a reason why in carrying out a statistic investigation, a sample rather than a complete population may be used. So this one we talk about sampling. So I think I told you before, right? So when you take sample, actually we are save our time and also we save the cost. Okay, so can you imagine or not? Because sample is a smaller group, so you just take a sample in a smaller group and then you investigate the data in it. Instead of you need to collect all the data from a very big population. So you save time and also save cost. All right. Okay, so now we go to part number 2. Okay, so Rose, she want to investigate men in her town. Okay, have a different lifespan from national average of 71.2 years. She looks at the government records for her town and takes a random sample of the ages of 110 men who have died recently. Their mean age in years was 69.3 and advice of the population variance was this one. Okay, so now how to know this case belongs to what case? I think I did a mistake here. This one should be case number 2, not case number 3. If I'm not mistaken, let us have a look. Okay, because first of all, she want to investigate the man in her town. Okay, and the national average is 71.2. So this question got some numbers that might confuse all of us one. Okay, so you see you have 71.2. She looks at government records for her town and takes a random sample. So from this sentence onwards, takes a random sample of the age who have died recently. Their mean age in years was this one. Okay, so maybe I will highlight until here. So 110 is the sample size. Okay, because I know that they are now talking about the sample now, a random sample of 110 men. So this is a sample size, a large sample size. And then the mean age. So they are talking about this sample. So when they are having the mean age, this one means the sample mean. So 71.2 is not, because 71.2 is national average. National average can be a population already. Okay, so you need to really understand all the numbers here because sometimes they might give you some extra number to confuse you. Okay, so I'm having n here. This is my sample mean. Then after that, they tell you a very important word. Unbiased estimate of the population variance was 65.61. So generally, this one means that okay lah, still consider as case number 3 lah, because originally they don't know the population variance, and after they estimate it, the population variance was 65.61. So originally the population variance is still unknown. Okay, that's why they need to estimate the population variance. So this is already the estimation for the sigma square. Okay, all right. So clear or not for all the numbers here? So if no problem, then you can start with the calculation. So they want you to calculate a 90% confidence interval for the population mean and explain what you understand by this confidence interval. Okay, so I think calculation part should be very, very easy lah. Okay, so sample mean is 69.3 minus the Z should be 1.645, and then 65.61 straight away apply, then 110. Then the same thing happened here. Okay, so eventually, if you round it off to 3 significant figure for your answer, you should get 68.0 and also the 70.6. So this is your final answer. Right? Okay, then now after that they ask you to explain what you understand by this confidence interval. So usually they will ask you also in some of the question they maybe will ask you what's the meaning of this confidence interval. Okay, so or like this they will want you to explain what you understand by this confidence interval. So there's a standard answer one actually, so you can just write out like that. The 90%, we are 90% confident that the population mean lies between these two values, lies between 68.0 and 70.6. Okay, so to me, I think this is the standard answer, the explanation. So every time you can just adjust the percentage and also the value. If let's say they want you to explain what is the meaning of the confidence interval. All right. Okay, then now we continue to part number B. State with a reason what conclusion about the lifespan of man in her town Rose could draw from this confidence interval. Okay, so they want you to make a conclusion. Okay, so by using this sample, it is 68.0 and 70.6. And just now they give you a national average, right? The population mean. So the population mean is 71.2. Okay, so is it this value in the interval or not? So you realize that it is not in the interval, right? Okay, so what you can do is you can write like this: the 71.2 is not in the confidence interval. Confidence interval. Okay, so you can write what's the meaning. So that means there's a significant difference in lifespan of men in her town from national average. Okay, so you can try to copy this answer and I try to understand it, which is quite obvious because for this confidence interval, right, she's using the, how to say, wait, can't find my cursor here. Okay, so for this confidence interval, she's using the data from her town. Correct? And then you realize that for this interval, if you compare it with the national, the population mean, you realize that the population mean is not in this interval, which means the sample here, okay, the sample here, the lifespan has difference. Okay, for this town has different with what they have in their country. All right, so this is the meaning of the question. So you can see that again, this is an understanding question. So you need to roughly know how to use a simple sentence to tell them the conclusion. All right, so there's no fixed answer lah, but generally more or less the idea is that it's like that one. Usually they will ask you to compare. If let's say the population mean is not in it, then the claim is not true, or something like there's a big difference between the sample and population, something like that. Okay, all right, so this is what we have for example 24. Okay, so let's proceed further. Okay, so for example 25. Okay, so for example 25, most of them based on calculation. All right, but I will just try to tell you why it belongs to case number 3 first. You can read the question. Okay, so here they said there are 50 cards chosen, and then the value that you get is blah 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 and so on. Okay. Okay, so if you go through with this whole question, first of all, you didn't see the word normally distributed. That's the first thing. And the second thing is in this question also, you didn't see anything about population variance. All right, so you know that the population variance are known. Because they didn't mention anything, right? Okay, and then the second thing is the sample size is large, and it's large. So okay. Okay, therefore you know that it belongs to case number 3. Right? Okay, so once you know that it is case number 3 already, first of all, they want you to calculate the unbiased estimates of population mean and standard deviation. Okay, so unbiased estimates is the estimation part that we learned earlier. Okay, the point estimator formula. So I'm not going through with this. You just need to calculate it by yourself. Try and see whether you get the answer or not. For the mean, it should be 10.5. For the standard deviation, if you round off to 3 significant figure, it should be 1.52. So that's the answer for part number 1. Okay, then part number 2, they want you to calculate 94% confidence interval. So if you didn't do any careless mistake, then you should get 10.1 as the final answer and 10.9. This is your confidence interval. Alright, then after that, the third part, they want you to calculate the width. So also very simple, you just apply the width formula. The answer should be 0.806, or they will accept also 0.807, either one. Okay, all right, so this is what we have. All these are basic calculation only, so I believe that there's no problem for you to get an answer. Okay, then after that, we continue further. A second random sample of 50 card is taken, so I have another sample, also 50 card. Okay, and then a 94% confidence interval is calculated using the sample value obtained. Find the probability that neither confidence interval contains the mu. Okay, so for this one, I'm having 2 samples here. This is sample number 1, and this is sample number 2. So sample number 1, I use it to calculate confidence interval. Sample number 2, I use it also to calculate another confidence interval. So they are asking that neither confidence interval contain the mu. So for sample number 1, when you calculate the confidence interval, it is 94%, right? So if let's say do not contain mu for the first sample or first confidence interval will be 0.06, 6%, so 0.06. Multiply with the second sample also do not contain the mu, also 0.06. So from here you get 0.0036. Alright, so this one is a bit special, that's why I show it to you. Okay, but also very basic understanding. Okay. Alright, so this is what you have for example 25. Then next one, you can continue with example 26. Okay, so example 26, this question, they actually want you to use the concept of confidence interval and to determine the sample size. Alright, so you can highlight it, all the keyword first. First, you see the word normally distributed, so it means population is normal. And then the standard deviation is 1.3, so that means the population variance is known. Alright, so now they said I want to have a 95% confidence interval with a width of less than 2.0. So this is an important word here, important phrase. They told you that width is less than 2. Okay, then they want you to find the smallest number of tests needed to achieve this. So the smallest number of tests means that the sample size. Okay, so again, this is where you should start up because this is the information they give you to let you start with. Alright, so what is the formula for width? So 2z sigma over square root n, smaller than 2. So you have to substitute all the value. So 2 is 2 lor. Z for 95% confidence interval is 1.96. What is the sigma? 1.3. And you don't know. And smaller than 2. So if you continue with this solution, your n should be equals to 7. Because n must be a whole number, right? Number of samples should be a whole number. The sample size, so n should be equals to 7. Alright, so this is what we have for the confidence interval question. Generally, the calculation part is very simple one, very straightforward. Okay, just that you need to know sometimes how to answer the concept questions. Okay, so again, to improve all this, you just need to practice more. More questions you practice, then you learn more. Alright, okay, then before I end this video, I realized that in some of the tutorial question, not from past year, but maybe from some other book, okay, you might see some word that you're not so sure. Okay, so let me talk about it here. Okay, so the formula for our limit confidence interval, right, is this one. Correct or not? Okay, sometimes in some book, they will ask you to find the margin error of mean. Margin or marginal error of mean. If you see this word margin or marginal error of mean, that means it is this value. Z multiplied with sigma over square root n. It is just a definition for this part. Okay, I realize that there are some tutorial questions, if I'm not mistaken, they use the word margin error. So a lot of students, they don't know what is it about. But generally, this is what we have. And then another one, they will also maybe ask you to find the standard error. Of mean. If they are talking about standard error, that means this is the only part that you need to involve in calculation, sigma over square root n. Okay, so this is something extra. If let's say in the future, in case you see all this word, at least you roughly know what is it about. Alright, okay, so that's all for this video. I will want to stop here. So we have ended the first part, the confidence interval for population mean. Okay, so for population mean, this is what we covered here. And then for the next video, we still want to cover the topic about confidence interval, but it is for population proportion. Alright, so please take note for confidence interval, we also have two parts. First part is for the mean, population mean. So the second part will be for population proportion. So for this population proportion one, I will cover it in the next video. Right, thank you.